time, and it just undermines and undermines, and one day you turn on a TV and you see a bust in a hole, and that's what happens. So, water running can cause these problems too. And so we are now going to start plague number 4, poorly designed homes.
We're talking about plague 4. We're going to talk about poorly designed home, but just poor design in general. It'd be my opinion that the designs of the home, many of the homes we inspect today, are just poorly designed. And here we have a couple that we're going to show you here. Come on, guys, it's not good to have a home up in a dead tree, would it be? But it's pretty. And also, you don't want to build your home on top of a tree. Just
a live tree.
A live tree.
That was a dead tree. There's a live tree, because they're both a problem. One's rotting and one's growing, right?
With the global warming, you don't want to have your houses on the iceberg. Okay, so what happens if the gondola breaks? You've got yourself a real problem.
And, painkillers and brickwork's not going to work, because this window probably is going to work properly. It's going to leak. It might be hard to close.
Okay, so here's something that the architect didn't figure out. There's going to be a road right nearby, but they dealt with it.
A pole dancer moved into this house.
Oh,
right?
was that the issue? So it was a good design for the pole dancer. Okay, so here we have a condo, and they forgot to tell the people that there was an exit, but they do have a nice balcony.
Just no way of getting to it.
It's just no way of getting to it. And of course, bad design when you got 2 urinals next to each other.
That might work for Siamese twins, though. Right?
So we have, here's just again, poor design. You got poor design, you got problems. You got poor design with roofs and gutters, mechanical systems, drainage, siding, foundation, interiors. All these could have poor designs, and they could all affect the operation and the longevity of the house.
So we'll go for roofs and gutters, okay?
Okay, and here's a classic example. You have several different types, pitches coming together. You have low pitches, and invariably you're going to have a problem with this. And you went inside, and we looked inside, and of course, what did we find? We found water stains everywhere.
And also, just so you know, when you're using asphalt pitch roofs, you really want to have a minimum 3 pitch, not a 2 or a 1, because wind can cause water to leak underneath these if they don't properly bond. So whenever you got pitches under 3, it should be a rolled roof or a rubber roof or a different type of material. Now, sometimes poor designs are kind of anomalies, and this used to be a house on a commercial street, and they realized, well, if the house was a commercial street, we could get more money for it. So what they try to do is commercialize the house, and they added a building up front, and then they they built the wall around the house so you wouldn't see the house, and you could see the house behind the wall. It didn't have a roof. And so this is probably not the best design. I don't even know, what kind of maintenance would be involved with this type of design. But this is how somebody wanted to change their residential house and turn it into a commercial house.
Okay, so here we have an Indian hut. And people say, well, this is a poor design. Well, actually, it's a pretty good design. The roof doesn't leak, and it stays cool in the time in periods when it's hot.
And you dry your clothes on the roof because it's a low pitch. It's a low roof.
Exactly. What's better? Do you use rocks or tires to keep the metal and or the corrugated asbestos on the roof? Either one works.
No, I think if you use the tires, then you have a mosquito problem, right?
Yeah, so probably the rocks are better to use.
I would use rocks. I prefer rocks over tires on my roof.
Okay.
All
okay.
right.
So thing that we run into a lot is that we have poorly designed gutters. And actually, it's just the house itself. They have a house that they have small gutters on them. They have no gutters, and you run into situations. And one just has to know about the environment that you're in terms of how much rain you're going to get.
And so if you're in an area, and if you look at this map that's getting 6 inches and 5.4, you know what? And down in Florida, you got 7.8. Maybe you install the bigger commercial gutters to handle more water. In California, you don't need the big gutters. Matter of fact, in California lately, you don't even need any gutters, do you?
No, it's coming. El Nino's coming.
And so here you got small gutters versus big gutters. And so you have to also calculate your roof. These big homes, they build these large homes with a lot of square footage, and then the architects forget about the additional water runoff, and they put these little gutters up there, and then they overflow, and they wonder why the basement's leaking, or they're getting cracks in the foundation, or their siding's getting dirty from the overflowing gutters. Also, a lot of times people call waterproofers, and they say, my basement's leaking, and the waterproofer says, yeah, let's waterproof. And, if you see the moisture way up in the corner, a lot of times it's where the downspout's been disconnected or where the gutters are overflowing. And when it's the moisture is up that high, a lot of times it has to do with the grading, overflowing, exterior poor drainage. Okay, poor grading is a big one too. So you're going to pay a waterproofer $15,000 to waterproof a basement, and all you had to do is maybe clean your gutters and change your gutters to a more effective gutter that would have had more volume for flow.
Okay, we talked about a bad gutter design. Here we have a small gutter, and we have a large expanse of roof. So water is going to come down here, and invariably, you're going to come in the wintertime, and at least in our region, and you're going to have icicles because it cannot take the flow of water. The water flows over in icicles form.
And if it overflows, then it erodes the soil, right? And sometimes you get moisture problems in the basement.
Now, here's a simple design that you don't find too much anymore in the U.S., but here in India, they had a flat roof, and they just shot the water off the roof onto the plants. And it acted not only something to water the plants, but also as a good way to get water off the roof.
Plus, you could use it as like an exercise chin-up bar. So it's multi-usable.
I guess you could. You're going to have to swing open. I'd be a little bit concerned about that, but I guess you could do that. Okay, so you got a gutter sponge. Bad design. Everybody hates to clean their gutters, and they're always coming up with new methods to do it. This was one of these ideas that I said would seem like a good idea at the time.
And what happens is, what the gutter sponge people forgot was that when you put up shingles roofs, they last 20, 30 years. And the granules have to roll off the roof, and where are they going to go? Into the gutter sponge. And then once the sponge gets filled up, then the dirt gets trapped, and then you have a gutter sponge garden. Would you call it gutter sponge garden?
I call it.
So you get gutter sponge gardens.
That was a group in the '60s. Gutter sponge garden. That was pretty good. I like that group.
Yeah. You went to Woodstock, right?
I did. Well, I almost made it there. Had a little problem.
So basically, these gutter sponges, now when it rains, they overflow. And when they overflow, the basement leaks. And this particular house actually called me for a mold problem in the basement. And they're like, what are you going on my roof for? And I'm like, well, the mold in the basement is probably being caused by water. And where's the water coming from? It's going over the gutter sponge. So these contraptions aren't the best. Another contraption is that helmet. And I'll tell you what, those gutter helmets keep the leaves out, but sometimes they don't keep the water out. The water overflows. And a lot of times they're very cold. And that, along with thermal bypass, and heat loss to the unconditioned attic space, and having this condition with poor ventilation, you get icicles, and that's a whole nother set of problems.
And also with these gutter helmets, if it rains very, very heavily, the water is just going to flow over the gutters.
And we're going to take this to the next level. Why we have icicles? Well, we have icicles because of heat loss. Now, here's a case, where the ductwork is in the attic, and you don't want to put a heating system or ductwork in a non-conditioned space because you're going to get heat loss, especially when you got these types of ducts which are flexible. They're not properly sealed, and you're going to get thermal bridging, thermal bypass, heat loss, and when you have the heat loss, and the snow melts, and then snow runs down to the soffits and forms ice. Here you see a thermal image of the heat coming out of the gable vents. Okay, so there's major heat loss. In this particular case study, we went up to New Jersey, and they want to sue the builder because not only the builder, they want to sue the builder's roofer because the roof was leaking, and they had us do all kind of mold testing in the walls, and we did viable and non-viable mold testing, and they're all getting sick by mold, and they're trying to turn us into a mold case because the mold is leaking from the roof. Well, what was really happening was the contractor and architect decided to add 4 new heating systems. It was $1 million+ home. and they put them in the attic. And so now there's major heat loss.
Without containment, they did not build walls around them, so the heat just diffused into the attic.
Right. If you're going to put heat HVAC systems in non-conditioned spaces, then you got to build some type of structure because you don't want to get the heat loss. So basically what was happening was it was melting the snow, and the snow was hitting this new roof, which the roofer did a nice job on, and it was causing ice, and then the ice back that went down their walls, and it became a big mold study. Now, I spent 6 hours at this home because these lawyers wanted me to test all the mold, taking mold samples in the walls and the floors. And I was about done about 4 o'clock, and I'm wondering, if I'm going to do this mold thing, I better at least get on the roof because I drove all the way to New Jersey. So I go to this back porch there, and you can see the back porch of that picture there. I climbed up there, and if you look closely to the roof, they have it covered with visqueen. So it was very slippery. So I'm like, all right, how am I going to climb up here? So I took my shoes and socks off thinking, okay, this works great. So I was able to walk up the visqueen. And then I got to the next layer, and that was asphalt. And as I started going up that roof, I didn't realize it, but it was like 180 degrees because it was a very hot day, and I started burning the bottoms of my feet. And I ran up to the peak, and I was kind of like dancing up there, hurrying up to take pictures, and I went back down. Then I had to go back down the roof that had the plastic, and I realized this isn't going to work because my feet were dirty from the asphalt roof, and now I'm going to fall off this roof. I couldn't get down, so I'm on the roof, sitting on the peak. Now my butt's getting cooked, and I'm like screaming, ma'am, and everybody left with this lady. And after like 15 minutes of cooking my butt, she came out. She goes, "Can I help you?" And I said, "Well, can you open up that window way up on the 3rd floor?" And she said, "Sure." And so she opened the window, and I had to climb through the window. And unfortunately, when I climbed through the window, I realized that the 3rd floor had white carpet. So now I can't walk on our carpet either. So I had to kind of like slide my butt all the way across the hall to a bathroom, and then I jumped into the bathtub and washed my feet. And that is my New Jersey story. Other things that can cause ice dams or thermal bypass is HVAC. Nobody thinks about this, but if your basement supply ducts are blowing, that's a good thing because you're pressurizing, and the cold air returns are sucking. But if the basement cold air returns aren't sealed, and we're talking, all the joints, and all the up and ups, the pans that go up, they all have to be sealed, and if they're not, they suck the basement. And when you got negative basement pressure, a couple things happen. One, you're sucking odors and moisture from your sub pump, you're sucking radon, but then you also have positive pressure in the upper floors. So if you've got access panels to the attics and canned lights, you're going to get heat loss, and all of a sudden you're going to get ice dams. So you want to seal all the basement cold air returns, and you want to open supply registers. You do not want your basement under negative pressure. Another thing you could do is when you're driving around and you see uneven snow melts. Here you could see snow melting, and you're going to eventually get an ice dam in that gutter, and that gutter is going to fall down. But if you went up to this house and you went up to the 2nd floor, you might see that they had an access panel or a walk-up or a pull-down or a hallway house fan that wasn't sealed, insulated, or weather stripped. And now if you've got positive pressure on the 2nd floor because the basement cold air returns aren't sealed and sucking the basement, causing negative pressure, you're going to have positive pressure on the 2nd floor, and you're going to have coupled with thermal bridging. And thermal bridging means that the attic access isn't sealed, insulated, and weather stripped, and so the hot air is going to go in the attic, melt the snow, and you're going to get an ice dam. Sometimes you see this. This is kind of odd. It's not that the siding's dirty, and you'll see this with vinyl, usually on the north side where it's cold, because in the morning it's cold, there's a dew point, and the siding's wet. So if you've got positive pressure on the 2nd floor, then the air's blowing through the outlets, through the switch plates, and into the inside cavity wall, blowing outside. And then the dirt and dust in the house impacts on the joints, causing plate out. And that's where you see the dirt staining.
Okay, go ahead.
Okay, and in this slide, if you have negative pressure in the basement, now you can also suck moisture out of your sub pump. And people, these waterproofing companies and builders put sub pump covers on. They're not 100% sealed. And so if you got negative pressure, you are now sucking the air out of your drain tile system, which could very well be stone odors, moisture odors, plus it's got very high humidity. And people run dehumidifiers in basements to lower the vapor pressure. In other words, remove grains of moisture, lowering the moisture levels in the basement, lowering the humidity. So once they do that, then the sub pump, which is connected to a high humid area with a lot of grains of moisture and a high vapor pressure, says, hey, here's some more. And then coupled with a cold air return that's not sealed, now that it's just sucking the sub pump, and you're sucking moisture right into the basement. And now you're going to have condensation problems on your windows. You might have mold in the attic. Okay, and in this particular case, the sub pump wasn't sealed. They had negative basement pressure. Okay, sometimes also what causes this is a humidifier on the furnace, or a ventless heater or ventless fireplace can cause this. So now the humid air goes up into the attic through the attic access panel or the house fan or the pull down stairs that aren't insulated, sealed, and weather stripped, and it causes a dew point condensation, and you can see the nail heads are frozen, and that's where you get that black mold in the attic. And a lot of times if you just look at the floor, you'll see little small stains or black spots, and that tells you that A, the house has an unbalanced HVAC system, B, there's a moisture generator, and C, there's thermal bypass. All these problems add up to a lot of other problems besides just ice dams. Now we have a mold problem, we have an indoor air problem, and a condensation problem.
Okay, so we got another, bad design, and sometimes just looking at a house tells you that something's not right with it, and something that is odd that you haven't seen usually. You really want to put up your antennas and say, "Hey, we might have a situation here." Well, we got a plumber who wanted to be his own architect and his own engineer, and he built this house. Now you look at this and. Have you ever seen a house with such a large vent stack from a chimney? Not really. I mean, there's a couple issues I could just think about. Are going to have. How do they seal it? How do they put flashing around that? It's a steel pipe. It was almost 2.5 foot in diameter.
And it was like 30 feet tall. And if you did the calculation on a solid steel pipe, the expansion and contraction of it from the sun hitting it or being cold or hot, this thing moves. I think we calculated that it moved between 1 to 3 inches. It would grow or shrink depending on temperatures. So the disclosure naturally read, chimney leaked and we flashed it. But it would always leak.
We fixed the problem.
We fixed the problem temporarily.
Okay, so here it is. This big pipe going right through the center of the house. And the design was that I'm going to have combustion gases from the furnace going up this pipe, and it's going to radiate heat into the house. So that's then it's going to be really nice because I could have my towels on this vent, and the towels are going to get heated. But you also wonder, okay, are there gaskets on those clips there? On those supports there, they're going to have the combustion gases coming right through there.
Right. But it would dry the towels. It would dry the towels. Now, the best part of this was he was a plumber. He also invented his own furnace. The whole basement was this huge heat exchanger. And his idea was, I'm going to heat this big steel vessel, and the heat's going to rise through the center of the house, and the surface area of my pipe is going to heat the rooms. Well, then he tried to figure out how he was going to heat this pipe. There was no products that were out there, so he had to go look for an old furnace, and he found these old gas valves. And you could see that where he took apart 2 different furnaces, old Niagara furnaces probably from the 30s, and he hooked up 2 burners in there, and that's how he was heating the house. Well, we all know how that ended up. It didn't work. And it didn't work, so then they had to add all types of modifications. So they had to add 3 separate water heaters. I mean, this furnace he also had water pipes going through it because he was going to get hot water from it. Well, they had to add in separate water heaters throughout the home. Then they had to add in a separate heating system. And so this house ended up having like 4 or 5 different heating systems because this plumber that built the house didn't do his engineering math work. And so if you've got a complicated home, sometimes they're going to be pretty difficult to operate. And this is a kind of a complicated home.
Okay, so here you have a situation where somebody decided to add a concrete fountain in the middle of the back wall, the dining room. Not a good design. It's very, very heavy. It's all poured concrete.
And it leaked. That's why there's no water in it. After he built it, it leaked because he didn't put in a proper waterproofing system.
Okay, and even the simplest designs in terms of stair height. I know stair height, we're talking 8 1/4.
That's for Ohio. Most of America is 7 3/4 for the riser, and so your risers have to be the right size. Now this one's almost like 10 inches, not even the code. So if someone were to fall, they could say that it wasn't built to code, and so stairs can be tripping hazards. Some of the older homes to third floors, back then they must have had little people, back in the 1930s and 40s, and we just happened to get bigger. I don't know if that's got anything to do with McDonald's. But we are bigger today, and these stairs are still small.
And again, the ASHI standard doesn't say anything about us identifying designs, but as a home inspector, I like to inform people of hazards in their home, okay? And I just tell them, caution these stairs.
But then the realtor's going to say, hey, that's grandfathered.
Well, that is true. It's grandfathered in, but Grandma could fall down these stairs.
Oh. I never thought of that.
Yeah.
Anyways, so then we look at decks. Everybody wants to build their own deck, and I would have to say that 9 out of 10 decks have problems. Some have serious problems. Like this one here has got serious problems. Here you can see they put the joist 4 foot on center, and they notched the wood. And so I think the next thing they're going to do is they're going to put a hot tub up there, right? And so always look at your decks, and sometimes you got to just think of, look at them from, you have to, it's just common sense. Okay, this is not going to work. This is a problem.
Okay, so this was a fairly popular design for a while in our region of the country, where they'd have the front of the house, they'd have 2 columns on the front of the house, and our next slide will show you here in terms of a little bit closer here the problems. Well, the house has been built out. They have the platform on the front, and what you don't see from the outside is that the base of these are separated from the foundation, and you have these columns going into the basement, and they're completely separated from the foundation. And so what happens, you have water accumulating underneath these. They've added stone. Sometimes the stone contains sulfur, and you get smells, and you also get rot occurring. Having the front stoop built into the front of the house is always problematic, just from the standpoint from keeping this area dry. You got water, wind-driven rain, it's going to end up in the foundation.
And another thing that happens, which kind of is more building science related, is that this actually communicates with the basement. Even though it's hidden by a joist pocket of insulation, you're going to get high humidity from the basement. It's not really high, let's just say 40% or 35%. And that humidity will go to low humidity, which is in this space that you can't see. Now, this space is not heated anymore, so it's outside, and when it's cold in cold weather design climate zones, a dew point forms. So now you actually rot this from dew point condensation continuously all winter long. And it may not even leak, but it looks like it's leaking, and it's not. There's dew point condensation occurring just like a shot or a scotch glass with ice in it on a hot summer day. And so after 10 years of this, now the house has got that musty odor when you walk in the door. Jim indicated the odors from the stone, because now the stone's getting moist, and if it's dirty limestone, you're going to get that musty stone odor. Then you're going to get carpenter ants, wood-boring insects, and some people may even be allergic to this stuff and get sick from it. This is a design that most of the country is building wrong, even till today. Now, I know that out in the East Coast and Boston area, this has been done differently, but here's the problem with this. This is a hole in your wall, and there's a lintel in there, and that's all there is. So when the brick above it gets wet, after long periods of rain, especially if it is facing the southern exposure, and you're in a high rain area, after some rain, that gets saturated and water goes down into the lintel. Well, they forgot to put in a nested gutter with weep holes. In this in this photo right here, you'll see where this gutter is supposed to go. It's supposed to get installed above the steel structural lintel, and then on the sides, they install weep holes. So this way, when the brick saturates, it can run down behind the brick, hit that gutter, and then drain on the sides. Well, they don't put those in right, and so they leak. And you will always see either stains or repairs. A lot of times the homeowners will have disclosure saying, "Oh, it leaked, but we caulked it, or we sealed it, or we reflashed it," and they're missing the boat because it's not leaking on the roof part; it's leaking behind the brick. And then you go into the house and you notice how this drywall has a completely different texture than the other ceilings, so you know they fixed it. And they always paint it before you get there, so you don't see it. They never disclose it. And if you use a thermal camera and it rained, you might get lucky and see the moisture accumulating. Other times they'll leave the moisture there because they forgot to paint it, and here you can actually see the moisture stain. So these will always leak.
So you have a 70-gallon tub that you got to fill in to get the whirlpool going, and you only have a 40-gallon hot water tank. You got a little bit of a problem because you're going to run out of hot water before you fill up your tub.
And a lot of times you go to these houses, you're in the kitchen and you turn on the water and you test it. And you're like, oh my God, you burn your hand off because the water's 150 degrees. And you wonder, why is it 150 degrees? Well, then you go upstairs and see this monstrosity. You're like, oh, they got to set it at 150, so they just run the hot water and no cold water. And when the hot water runs out, it gets cold and it's just enough to fill the tub. So in the meantime, they're burning their children and their hands just so they can fill this tub. So you're going to put a big tub in, you better calculate what size water heater you need.
What I would consider more bad designs on this roof. Now, we don't usually inspect out structures, but I felt it was my obligation to tell the prospective buyer that maybe they want to have actually a structural engineer to see if the support of this roof is satisfactory. What do you think, Marco? Do you think that stone is okay the way it's tilted like that?
I think so. I wouldn't probably land a helicopter on it.
Oh, we just basically told the client, don't park your car underneath there. Okay, we're going to talk about plague number 5 here. We call this construction process problems. These are problems that arise in a house due to problems with construction. They did improper things during construction, and it manifests itself down the road.
A lot of times, this obviously is a picture of winter protection. If you're going to lay brick, you got to heat and cool it, and you have to protect it from the weather, otherwise the mortar freezes, and you get efflorescence problems and cracks. And houses is no different. A lot of times these builders build houses in the winter, and they have problems with the drywall cracking. They leave water in their basement, they get mold going on the joist. And so winter protection failure in residential and commercial is very important, and just weather protection in general. This is the YMCA. I remember seeing it on a Friday. It was like, 5 degrees. It was very cold, and nobody showed up until next Monday. And during that time, you could see all the brick mortar joints that just got done laying, because you have to keep that heated. You can't let that freeze after you lay brick in the winter. And so now this whole YMCA is getting cracks and efflorescence coming through. This is just a year later. Actually, it looks worse. They keep cleaning it. Concrete placement problems. A lot of times you pour concrete and within 1 year it starts cracking and then pitting and spalling, and then the contractor says, oh, it's the salt that you put on there, the road salt. You know what? It's not the salt. Because what I do is when I have these complaint calls, I would go down the street and look at everybody else's driveways, and I look at the ones that are 10 years old, 20 years old, and then the one they just poured, and the one they just poured is the only one that's got salt damage. I don't think so. And it's the way they pour it. You could have a high water cement ratio. They may have not had enough finisher, so they splash water on it. It could have been a hot day. It could have been a long, the load may have been in the concrete truck too long, and they kept adding water to it, and there was no air entrainment, etc. And there's a lot of things that can go wrong with concrete. So I always look at the neighbor's concrete. Here's another one. This concrete's 40 years old, and the other one's 1 year old. And actually, the 40-year-old one's actually better than the one that's 1 year old. Then, when they pour concrete, a lot of times they do poor grading, and now all of a sudden the buildings start leaking. And so this contract put in all new sidewalks in the whole town. And then all these buildings started leaking. They started getting mold, and their ornamental wood started rotting because they didn't do the proper grading. And then material storage too. When if you're going to build in the winter, you better protect your material. Here you could see that the wood is not really wood; it's a plastic type wood, and it's cold. And so when they nail that in, if that's not acclimated or installed at proper temperature, it's going to crack, or it's going to shrink, it's going to expand, and all kind of problems. Plus,
and going back to the acclimation, I mean, on many products, they say it must be the same temperature. You got to take the wood flooring. You can't let it out in the winter time and take it inside and install it because it will shrink. You'll run into all sorts of problems. I remember one time I did a job with cork. The lady wanted me to put cork on the wall. And I told her, I said, it's supposed to wait a day to acclimate. She goes, put it on. So I put the cork on, and sure enough, 3 months later, all the cork shrank. And she goes, what happened, Jim? And I said, you didn't let it acclimate. Very important.
And on that same note, a lot of siding, if you put like vinyl siding on the house and it's 90 degrees, or you put it on a house that's 30 degrees, you're going to have problems with the siding. So you need to know what type of spacers to use, how to nail it. And just like Jim said, you need to acclimate certain products, and you need proper material storage. Here's one where they use straw. They poured concrete in the winter, but then they pushed the straw into the sewers. So what do you think is going to happen? All right, this one here is a case study, and we're gonna call it the attack of the sewer flies. And this is basically goes to poor construction of a sewer installation 40 years ago. Okay. So this couple bought a house 3 years ago, and the home inspector said the hot water and bleach will kill the flies. When they inspected the house, they saw a couple of these flies in one of the showers, and my client says, what are these flies? He says, oh, they're sewer flies. Just put some bleach down the toilet. Well, you know what? 3 years later, the flies don't go away. They hire all kind of pest companies, and the pest companies use chemicals. They don't work. The pest companies go on a roof. They put chemicals down the stacks. Doesn't work. Then they use sewer snakes, and they snake out the pipes. And they look at the sewers after they run the camera through. They notice that the clay tile isn't connected in a few areas. So when they flush toilets underneath the house, it was a slab house, the water would leak at these joints and leak underneath the slab underneath the house. So, okay, let's start digging. Let's dig it up and see what's going on. And now we have to tunnel. So now we're going to tunnel underneath the house and fix these pipes, because what's happening is these pipes are leaking, and underneath the slab, the temperatures are 70 degrees, and that is the gestation period of sewer fly larvae. So the sewer flies are living in the soil with warm water from the tubs at 70 degrees, also coming from the dishwasher, and they're living underneath the house in soil cavities. And also, there's always a small gap between the soil floor and the top of the concrete slab. And they were kind of just, flying around on in there, and they would come up through cracks, shrinkage cracks in the concrete. They would come up through walls where there's penetrations, going through the concrete, at construction joints, at cold joints, and those areas. So we started a tunnel, and we kind of had a tunnel underneath the whole house. These clients did not want to move. They just spent $100,000 rehabbing their upper unit, and they did not want to spend 3 months in a hotel. So they were not going to let us replace the plumbing system, and they were not going to let us cut the floor in the house, because that would totally damage our house. Plus, this house happened to have a hydronic heating system that had hot water pipes traveling through the concrete slab. And so it would have been a major expense. So we had a tunnel. So as we were tunneling, we're jackhammering and running into all types of footers. And then we start seeing cavities, and we start seeing maggots. And so basically these things were leaking. As we were tunneling underneath this home, you could see the concrete above us. Sometimes we had to build walls. We had to put up beams to hold the upper structure from collapsing. And we basically had to make several tunnels underneath the whole house. We started a second tunnel underneath the kitchen, because that was weird. We did all types of dye testing, and when we ran a dishwasher, the water just completely disappeared. And apparently we found out that the last homeowner had blockage of the sink, so he'd run down the street and buy Drano every week, because we talked to a neighbor, and he must have been putting Drano into his pipes for decades, to the point where the pipe completely was eaten out, and you could see the pipe was eaten out in this picture. So every time the water came from the dishwasher in the kitchen, or the hot water, or the garbage disposal, it would leak underneath the slab. And that was another area where these maggots of these sewer flies were living. This is the gap underneath the concrete, and where the flies were able to fly around and gain access. And so basically we kind of worked through the entire through Christmas. And so what we did is we actually decorated the tunnels with Christmas lights, and basically the whole project cost $63,000.
Okay, so we have other construction process problems. We got this is a show of a non-qualified worker. We have, for a couple of reasons. This guy's not qualified. Of course, he doesn't wear proper pants. But you get what happens during construction. You get out of order installations. They do it improperly. You get low bidders. Okay, they're going to go with the cheapest guy. Well, he's going to be. They give you the cheapest work. And you got certain products that are prohibited by city code. The people use them, and they shouldn't be using them. There's a reason that they shouldn't be, but they still use them. And then also you have the newest codes, and people just aren't familiar with them. So we have other construction process. This is a little bit better. This plumber was a little bit better. Of course, she did have problems with her belt too. Okay, we're going to move on to plague number 6 here, called material failures. And we have a shot of this. These wrought iron stairs up here rusted out. I was at this job and I heard a scream, and you found that one of the realtors had stepped onto a step and had fallen through. Fortunately, she didn't go down very far, but this is one of the reasons that you have construction failure, material failure on a site.
When you're buying these condos, a lot of these buildings that they're refurbishing and rehabbing and turning them into condos or even apartments, if they're condos, you definitely want to look at the exterior stairs. If they're like old, chances are they're rusted, and you'll see all these plates and re-welds and metal plates, and the welds are getting bad, and the bolts are rusting, and then they paint them and caulk them, and you can't see this. So it's very important to look at these. To repair a set of stairs like this can be very expensive, and if you're buying a condominium association, you may be looking at some future huge assessment. Another place to look at is under parking garages. You buy these high-rise buildings, these condos, and you think you're buying a condo, but you're really buying everything. So you need to look at the siding and the facade. You want to look at the windows. Who's responsible for the windows? You want to know how old the roof is. You want to know how old the cooling towers are at. And then one of the biggest expenses are the parking garages. And what happens is with these parking garages that the salt goes through and into the lower parking garage, and sometimes there's several layers, and that can cost $1 million+ to repair these parking garages. And so always look not only at the unit you're buying, you want to look at the parking structure, go in the basement, even though it's not your spot, just look at the whole thing. And then most importantly, I tell my clients to get 12 to 24 meeting minute notes, because the board will have a monthly meeting, and in that meeting they're going to talk about any problem. You want to read those. Another thing you want to get is obviously the bylaws, rules, and regulations, and see if there's any assessments. But a lot of these associations will have engineering expenditure projection reports. They're like 10 to 20 year expenditure projection reports that tell you what will need to be done between now and the next 20 years and where they're going to need more money. And so very important. That's actually more important than inspecting the unit.